Welcome everyone, whether you're joining us live or on the recorded version later. This is our weekly SQL training for the 70-461 certification SQL queries. We are today going to be covering aggregating data and aggregation strategies. Again, this is being brought to you by Emergency Reporting. My name is Steve Stedman. I'll be doing the second half of the presentation. Aaron Buma will be doing the first half of the presentation. At the end of the presentation, all the material will be posted on my blog, stevestedman.com, to be able to download the PowerPoints and the SQL queries.
So the first section we'll cover is aggregating data. We're going to go over the basic functions, what you can do with those functions, and then filtering around, or when you include those functions, filtering on the functions or filtering on non-aggregate functions, and then the having clause with distinct clause. So these are the basic aggregate functions. There's a few more, but these are the most common ones that we come across. Most of the functions are you put a column where the expression is in there. When you do a count, you can have a count star or count one in each of the columns.
Are there differences in performance between the two?
In SQL 2000 and prior to that, yes, there was. The count star would return all columns to the result set, and then but only display the count out to the user. Where count one at that point in time would just count a variable, so it wasn't returning a result set. It was returning a kind of hard-coded column. So it was faster, better to use, but now SQL Server will translate count star into basically a count one and just return the count of the results. So it's smarter now. All right, so we're gonna get into some examples. This script here is part of the sample scripts, and what it does is it just drops and creates a database, creates a table, and fills it. And the sample set we're going to be using today is around inventory. So the category of an item, the SKU, kind of like an item number, description, quantity on hand, the unit cost, the retail price, unit retail on whether it's archived or not. So first we're going to look at what those sample here's our data set. We're going to look at what those simple aggregate fields do. Let me make this result set bigger here. Okay, so we can see here that here's the sample set. So we have 1 axe, 2 food items, 3 sleeping bags, and 1 tent. And in the second query, I just pull out the category. Actually grouping on category. So we want a count of each item SKU, so we can see that there's 1 axe here, 2 food items, and 3 sleeping bags, and 1 tent. The next one is the sum, so total. In the axe category, we sum up the quantity on hand. There is only 1 on hand, so the sum is 35. For the food items, we are still doing the aggregate on quantity on hand, and the sum is 6 items. Sleeping bag, 19 items. Tent is 5 items. And then the minimum for an axe is minimum quantity on hand is 35 because there's only 1. The minimum food max is 1. And the min for sleeping bags is 1 and 5, and then max column is kind of the opposite of that. And then the last column is average, and then average just averages out between all of the data rows that you are doing the aggregate on.
So on that query, the group by, how is that impacting the results that you get there?
For each row that contains sleeping bag, it does say the average of the quantity on hand.
Okay.
Any questions? No.
Would that have worked if you didn't do group by?
All right. So this. So it won't work. So if you wanted to include a if you don't include any non-aggregate rows, columns, it's okay to do these aggregate functions because you're basically grouping on the whole table as one.
Either have to be all aggregates or no aggregates.
Yeah.
When you don't have a group by.
So yeah, we can pull all these out, comma back in, run it. This is the count of total rows in the table, possibly, and we'll get to that later. And then the sum and min, max, and average of the quantity on hand column.
So keep in mind as we go through this, some of this might seem basic if you've used these before. In preparation for the exam, we want to make sure that everyone's covered on everything, so we're not overlooking anything.
And there are a few gotchas in here. It's very simple on the surface, but once you get in there and play around with it, then you kind of learn the details, like how does it account for nulls when you're doing a min or a max or a count? How can you group on multiple fields? What does that look like? And how do you order by aggregate fields or non-aggregate fields when they are mixed together? So for setup for this section, we will null out one of the item SKU fields. So what we're going to do in this example is how many items, what do you think the result set will look like for this second query here? We're going to have category on one in the first column. So an axe, and it'll probably be a 1 because it's a 1, and then it will be food, maybe 2 or 1. What do you say? We think it'll be 1. The sleeping bag 3, tent 1. So we'll run it. And the result set is a food of 1. So depending on what your data set is, you might be getting less results than you really are not really there, if that's what you're expecting, if you want that to come back. So how do we account for that? By accounting for nulls.
Nice.
If that's what you are looking for. If you want to include, if your data is kind of dirty, you want to be able to account for nulls or any other kind of offshoots. Okay, so the next one, grouping on multiple fields. Okay, so we'll set that data back. On this one, let me get rid of these results. So we need to, we want a count of categories of items grouped by category and their retail price. We want to know how many of each category have the same retail price. With that example, you can just add on another 2 non-aggregate fields and then count the aggregate field, and then you need to add them in the group by, of course. So you can see here's the raw table, 3 sleeping bags, They each have their unique SKU, and there are two items that are $19.99 and one is $14.99. So here's a count of the items by SKU, and then we can see that adding that second aggregate field breaks it down further, showing the category, how many are in each category for each category, and unit retail price. Okay, now how do we order the results? For that last result set here, category, unit retail, and item SKU, or sorry, account of the SKU. We want to order it by the most, or the highest count, descending.
We have to name it. We have to name it. But, yeah.
You want me to put this down here? Okay, we'll try that. Run that. Yeah.
What would have happened had you not had that?
So what's the difference between these two these two lines here? What you suggested, Gabe, is we are ordering by the aggregate, whereas the original one will not work because it is not ordering by the aggregate. Correct. So good job on that one. That was the answer.
What if you got that in count again?
So what this does is it is performing the exact same logic as using the alias.
Does it actually count twice then? Or is it-
Yes, it does.
Okay.
Yeah.
So it's less performance.
Yeah, it's less performance. But clean code, I would say probably put the alias down in the order by to help with the next person looking at it. So this next section is filtering on aggregate fields. We will run. So without knowledge of aggregate and how to filter on aggregate, you might try having a min, like where filtering in the where clause with an aggregate. And why I should have ran this after asking the question. But why would you suppose this doesn't work here? It has to do with how SQL processes the order of operations. So first it processes the from clause. It goes out and gathers all the tables in the query. And then it will use the where clause on the columns, non-aggregate columns in those tables that it just went and grabbed. Then it will group by all the results in there. And then when you throw on the having clause, it will perform, since it's performed that aggregate function already with the group by, then it will apply those filters on the results of that group by and do the output. You can see that we wanted to show all the categories where the minimum quantity on hand was less than 5, so we're starting to run a little short.
So in that case, would you say the having clause is just like the where clause, other than where it gets processed instead of at the beginning of the work, it gets processed at the end?
Correct. Yes.
Okay.
So we can see that sleeping bags showed up because the minimum, one of the records in there was below the threshold on the grouping. And same with the food category. What about filtering on, throwing in a filter on a non-aggregate field? Since that happens in the where clause, you can have a where clause and a having clause at the same time. We wanted to filter down our initial query that we just ran to get the minimum quantity less than 5 for each category. We want to filter that further down to sleeping bags and see if there's any sleeping bag items that where the quantity was less than 5. And since that filter occurs on the data set before any other work is done after the from, it can go in the where clause. So what if you want to include an or clause? So we want to do less than a quantity less than 5 or the category of sleeping bag. How would you suppose you write that query?
You could just do those. You could, I mean, the category equals sleeping bag could be in the where or the having. It's just more performance the where, do the filtering there.
So you're saying select category, just for the microphone here, selecting category, and then minimum quantity on hand is smallest on hand, from inventory, group by category, having the min quantity less than 5 or the category equals the sleeping bag or whatever we wish to filter on. So acts per se. And see that there's none in there, and you were correct.
Nice.
We can.
You said it's less performance.
Well, it seems like it would be because, I mean, it's just when you're dealing with you're cutting down that set, right?
Yeah.
But are you running over the same amount of rows?
No, so think of it, if let's say you got a table with 10 million rows in it, and the where clause happens up front,
Right.
and it's going to filter that 10 million rows down to just the subset you're looking at, and then it's going to do your aggregation on just that subset. And then the having is going to go against just that small subset as well. Whereas if you put everything in the having and nothing in the where, it's going against all 10 million of the rows and making them all aggregate.
Yeah.
Does that clarify?
Yeah.
Okay.
Distinct filtering on aggregate fields. So there's a distinct clause which you might have seen that you can put in the select statement, and we'll go over how to include that when you're using aggregate fields, and does the distinct account for nulls. And you guys all know what the distinct, for those that don't, we'll run it, and what it does is it filters out duplicates out of the result set. So it returns all the results, and then before it just performs the output, it just filters it down, removes all the duplicates for each column that's included in the result set.
For every column.
Yeah, for every column in the result set. Well, these two queries have the same result set. We're going to get select the category, account of each price in the category. Let me just do this real quick.
The only difference there is distinct.
So you guys can look at the data. So do you think these will have the same result set? So a category and a count of the category, or count of the price. And the next query is a count of that distinct prices per category.
I think you can get one of the duplicate 19. Three.
This one here. The first one count each individual row, the second one perform the distinct function. All right, so let's update one of those prices, say that $14.99 to null. So we'll try that second query again. That used to return 2 results. Do you think it will return 2 again? Jury's out, so we'll just run it. No, it does not.
This is crazy. I
So,
would think null would be this thing.
but null by itself is not a value, it's a state of a field. So, yeah, that's something you really have to pay attention to when you're using counts and aggregate fields. I don't think I have an example of this. I might higher up.
Just make all my columns not.
No,
Null is ignored by count and other aggregates.
Yeah, it's ignored by other aggregate fields. I might have, let's see here.
yeah, I mean, it was returned with the distinct, it just wasn't counted,
Yes, yeah.
so.
Uh,
Oh, interesting.
So items. All right, so question time.
So, sorry, just reiterate what I think you just said.
Yeah.
So all aggregate functions ignore nulls. Or don't count nulls, or,
Correct.
Yes.
okay.
And the way you can deal with that is use the is null
Right.
option, which you can see the video from last week you missed on how to use that one.
Yeah.
So,
So here's, not sure if the data has been changed at this point. We can rerun the setup. Rerun this. And then here's a way to account for nulls. The is null fit account is a null value. It inserts a empty string tick and includes that in the count. So food shows up as 2 values over just 1 value. So this will perform the aggregate function in 2 versus just 1 value. Okay, so first question, you have this data set. Excuse me. How can I get a count of the vote sum? This was a question I grabbed off of Stack Overflow.
Relevant. Counting user.
okay.
All right, so this is from using the data set and the samples we were going through. What would be a query that would give me the total cost of inventory on hand, which is the unit cost column? There you go. Select sum quantity on hand times unit cost as total cost of goods on hand. So yeah, we covered the basic aggregation fields functions. You had a question if something needed to be in the expression field, and there does have to be something in there. You can put hard-coded values in the sum, but that kind of defeats the purpose. You'd put a column in the sum, the min, the max, or the average. Counting, you can count. You can put a column in there, but you need to account for nulls. If you have nulls in your data set and you actually do want to count those as a distinct row. Or you can put in a hard-coded value or a star if you want to just get a blanket count of everything in the result set.
Are there other aggregate functions?
Yes.
The main ones?
Yes, and actually there's a bunch of them around statistics and ranking and things like that. And next week we're going to cover a bunch of ranking ones, and then the statistics ones we'll get to later. So.
Okay. And then we went on the halving clause, how we can filter on aggregates and non-aggregate fields. at the same time or against each other, and then how the distinct clause factors into aggregates, both inside and outside of the aggregate functions.
All right, so jumping into the second half of it, aggregation strategies. I've got the same database that Aaron was using here with about the same stuff in it. And I'm just going to drop the training database, recreate it, and refill the inventory table to make sure it's back to that known state. We'll be using that in just a moment. So what we're going to take a look at here is the over clause, which is a really cool way to be able to go and take your group by, or take your aggregate functions and apply them to a specific chunk of data that doesn't necessarily correlate with your group by. And that's, you can, so imagine if you could do multiple separate group bys in the same query. That wouldn't make any sense in SQL Server, but conceptually what the over clause will do will let us apply those aggregates to multiple or different, they call them windows often, different windows of data that are different than what you're grouping by. Partition by is how you can divide it up, and group by, we'll see how the over clause works if you're using over and a group by, and then we'll take a look at some performance on that. So the over clause was introduced in SQL Server 2005. Seems like all the really good stuff seems to have been introduced in 2005. Before that, it was pretty hard to work with SQL Server. Let's just, so I already mentioned aggregation, but these are also known as the window or windowing functions, meaning you've got this huge set of data and the window is providing you a different view of that aggregate data than you would get with a group by. Let's just jump into the code and take a look at it then. So just to make sure we're not cheating or haven't made any mistakes here, we're going to look at what the inventory table looks like, and I think it looks about the same as what Aaron was using a moment ago. So we'll go back, just a quick review of what we looked at, and we'll just run both of these, or we'll run the first one. So the first one is average unit retail by category. And so you can see what this is doing is it's selecting category, grouping by category, giving you the average unit retail and the count for each of those. So this is exact same stuff that Aaron covered just a moment ago in the presentation, but then we're going to see how to change it here. So then we can change up what we're averaging and counting over by changing our group by here, knowing everything that just came out of what we just learned. And so if we run the both of those, you can see that we get different results. This is grouped by category, and then this one's actually grouped by the unit retail price. So that's grouped by the retail price. So we can see, like here, as we saw before, there's two items that are $19.99. And by changing the group by, you're able to get different things that you're averaging over here. But what if you want to, in this case, average the unit retail over categories and over unit retail? Let's take a look. What we can say, or what we can do to, if we want to look at average unit retail without using a group by category, let me just show an example here. If we took this query, I think Aaron showed one like this previously. If we do an aggregate without a group by, you get this error message that we saw earlier. But if we throw in the over clause, which is saying take this aggregate function and apply it over, and inside of the parentheses, I haven't specified anything. So it's saying apply it over the entire table. It's going to be the same as doing select star with an extra column in front that's average over the entire table. So we run that, you can see no column name because I haven't given it an alias yet, but the average unit retail over the entire table is 41.11, etc. there. Because of how the over works rather than a group by, we're still getting one row for each of the original rows in the set. Does that make sense there? So then what we can do, just because this is ugly with the no column name here, is we can just tag it with an alias, and when we run that, we get a column name showing up there as average unit retail. All right, so that's kind of the basics there, and I know to get started, but let's take a look at using two different aggregates using the over windowing clause without any group by on it. So here we're going to say, give me the average unit cost over the entire thing, and the average unit cost, and if it's null, set it to 0 over the entire set. So you can see here the unit cost on this bottom item, which has an unprintable name or description, which is a food item, there is no unit cost. So if we run this one, we learned earlier that nulls don't get counted in any of the aggregate functions unless you use the isNull to turn them into something. So we can see here the average unit retail, if we average all of these out without the null, is $5.45 and 2/3. But if we take that null and convert it to a 0, it takes the average cost down to 4.6 or $4.67. So you can see how using the over clause, we're able to go over the entire set of data. Using the isNull, we're able to convert the null to 0 in this case and include that in our average. And it makes me wonder, how many accounting reports and different things do people have out there in the world where they didn't consider the isNull and they're reporting like an average or a sum or something that's getting thrown off by that null value. So here, both columns we're looking at are unit cost. We could have done most of that with the group by, however, we wouldn't have got multiple rows back. But what if we want to look at two different columns? This is grabbing both of these over the entire set. So the average of unit retail will be the average of all of these, and the average of quantity on hand will be the average of all of these over the entire data set. So the average, as we saw earlier, is 41.11, and the average for the quantity on hand is 9, because all of these here average out to be 9. And again, we can take those and we can tag them with aliases here so that the column names show up with nice titles on them. We're able to do things here where we're getting these averages that get copied for every row, as well as all the row data, which is different than what you were able to do with the group by clause. Technically, you could have done multiple queries, one that gave you the group by and the other that gave you all the data, and then sort of cross-join them somehow or to get this kind of result set, but it's just a lot easier using the over clause. Let's take a look if we want to determine how far the retail price is from the average retail. So here I'm going to select in one column the average retail cost, which we already looked at before. We know that was around 41. And then I'm going to, because the way the math works out here, it comes out negative. I'm going to take the average cost over the entire set, which is that same 41 that we're looking at, and then apply it against unit retail. And you can't really do this in any way with the group by. So I'm going to take this 41 and do math against this unit retail over here and come up with a number of how far 1999 is away from 41. And I'm going to subtract that whole thing from 0 so that it comes out as the positive number if it's higher or a negative number if it's lower. So let's take a look at that one when we run it. So here we can see that the 41, that this has been calculated, and then the math is applied, taking that 41 over the entire range, applying it to the unit retail over here, or in 1999 is $21 less than the 41 here. Now, I don't know of any way to do that kind of thing without some pretty elaborate multiple queries and subqueries and whatnot with a group by, but the over gives you the capability to do some really cool stuff here on trying to come up with aggregates or apply data across your data set that then has math applied to each row.
So it's not possible to use the average unit retail alias in your second field.
Oh, instead of to take this,
Take that and
right, and put it here,
put it there.
right here technically.
Yeah.
Yeah, that one, it doesn't work
It wouldn't work.
because all of these are kind of being evaluated at the same time, and the column doesn't actually exist yet.
Right.
Now, you could have probably done something like this by doing a subquery and then doing math on the columns coming out of it with group by, but that would be really ugly. So using the over is just much cleaner, in my opinion, than a lot of the ways that people end up using group by and running multiple queries against it. All right, so let's go back, take a look at what we got in the inventory table here. Same thing we've been looking at all day. So now if we want to look at the count per category, Now, Aaron showed a demo earlier like that where it showed the number of sleeping bags, tents, axes, and food using the group by, but what if we don't want to use the group by? So if we just say, give me the category and the count, it says, hey, you can't do that because it's not contained in an aggregate function or the group by clause. Okay, so you're thinking, well, the only way out of this is an aggregate function or the group by clause. Well, that's not true, because there's another way we can do it here. If we look at it and say, we could go the old way and do a group by and then say your category, and that's equivalent to what we saw earlier in the session where axe, food, sleeping bag, and tent comes out that way. But what if we, instead of doing the group by, and notice I'm going to leave off the group by when I highlight this here, I'm going to say, give me the count. Oops, actually, no, I need the group by because this one does not have an over clause on it. And I'm going to give you the count items per category, which is being grouped by the category here, and then using the over clause, which is saying, give me the count of everything in the table. So when we run that, we can see there's 1 axe, 2 food, 3 sleeping bags, and 1 tent. But there's a total of 4 items. But hold on, if we go think back to our original table and we add up all of these, 1 plus 2 is 3, plus 3 is 6, plus 1 is 7. There's really 7 items in our table, but why are we getting total items of 4? Where we go, this one here.
Is it because the over clause is applied after the group by has occurred?
Yes, exactly. And if we think back to the precedence list that Aaron showed earlier, I don't have it to show here, but the over clause on the result set there is happening after the group by. So the select statement's getting all the data to be processed. There's no where, so if there was a where, it would be filtering that out next. It's doing the group by, and then this count is applying to those things that are grouped, and then it's counting the number of rows overall that are in that grouped result set. But that's not what I want. What I really wanted to see was 7 over here, so I could do the math and say, well, what percentage of the items in our store are in this department? So the way we could take a look at doing that is, let's dump the group by. See, this group by is falling off the query here. We're still selecting category, but we're saying, and this one's the same here, count over as total items over the entire table. But on this over clause, we've thrown in a partition by category. So what this is doing is it's saying, give me a sum over the specific window set, and that windowed group is category. So it's kind of like saying, just for this one item in the select result set, we're going to group this by category. But the rest of the table is going to show up as though there's no group by. Let's see the result and see if it does. So here I can see there's 1 axe, there's 7 items. There's 2 food, there's 7 items. There's 3 sleeping bags and a total of 7 items and 1 tent. But that's still not what I was looking for. What I really was trying to get was 1 row for axe, 1 row for food, 1 row for sleeping bag, and 1 for tent. So that's where the distinct keyword comes in. So I'm going to take this result set and just say, make it unique. Throw out all the duplicates in the result set, meaning give me distinct items. And when I run that, I now get 4 rows, a count for each category, and then the total number of items.
Yeah.
So now, like what I mentioned, what I really want to do is to figure out percentages. I'm going to do some math here. And this 1.0 is kind of a quick way to cast it from an integer to a float, because count comes back as an integer, multiplying by something with a decimal on it converts it to a float. And I'm counting that, partitioning by category, same thing we partitioned by here, dividing by the count 1 over the entire thing, and multiplying by 100, which is the math to say, hey, give me a percentage. So when I run this, we get this other column here, and we can see that 14% of our product is in the axe category, 28% is in the food category, 42% in sleeping bags, and 14% in tent. Now, I don't know how you could accomplish that with the group by without writing many queries and bringing the result set back and doing the math on your own in some convoluted way, which before having learned all of this, I'm sure I've done that kind of thing on multiple occasions. But this can really simplify the code that you're going to use to process your result set once you get your data back.
And speed it up.
Yeah, and speed it up, because the database is going to do a much better job of figuring all this out than you are if you're bringing it back to PHP code or some application or something.
If you have a very large data set and you are doing this partition by on like 100 columns,
Yeah,
it seems like that's inefficient. Is it doing the partition by is basically grouping the entire data set again?
yeah. So hold that question. I've got a sample at the end that shows that. But yeah, it's a really good point. It is inefficient compared to not using it, but it's more efficient than other ways to get the same result set by not using this. Does that make sense? And I'll show you at the end of the session, I've got some stuff that actually shows how that happens. All right, so what we're going to do now is move into a little bit different table here. So same database, I'm going to create a table called team, which has an ID, a name, age, gender, and archived. And I'm going to insert into the team. They're all
Not alive anymore.
okay. They're all dead, but they're founders, and they're all people who were involved in 1776 in somehow in signing of the Declaration of Independence or in the Revolution at that point. So let me run this. We get 13 rows in the table. I just thought this would be a fun team to work with. What really amazed me when I looked at the data here was how young some of these people were. Like, you think about Thomas Jefferson. I mean, you see him, you always think of him as an old guy, right? Well, he was 33 years old.
Wow.
And like James Madison, another 25 years old. But James Monroe, 18 years old. Betsy Ross, 24. I mean, you think of Betsy Ross, she's the one who sewed the first flag, right? All the pictures they show of her sewing that flag, she seems to look like an older woman, but she was 24 at that point. So let's just take a look here then, now that we've looked at some of those ages, at what we can do with the over clause and some partitioning. So I'm going to select everything out of the table. I'm going to take the average age over the entire data set, because I don't have anything in the over parentheses here. I'm going to take the average age partitioned by gender. So all the men, their average age, and all the women, their average age. Okay, there's only one woman in the list right now, and she's 24. So we know that number is going to come out to be 24 for the women in that one, or female in that one. And then the average age over archived. So I just, not that there's any reason to archive these, but I threw an archived bit on 2 of these saying, well, maybe these guys are no longer employed, or they've gone off to do other things after we're done here. So there's 2 of them that have an archived bit. The average age, their ages are 44 and 53, and then everyone else is going to be averaged out with this partition by. So let's run that and take a look at it. Okay, so we can see here, as we get 1 row for each row that was in the table. You get, because we said select star, it's giving us everything out of all the rows. The overall average, so the average age out of all of them that are in this list is 32. Which, historically speaking, I was really surprised by that for the people who were involved in the Declaration of Independence at that point. Then we've got the average by gender. So as we speculated, there's only 1 female on the list, Betsy Ross, she's 24. Therefore, the average age of all the females, just one of them, is 24. And then the average age of all the males is 33. Okay, so then we look at the average by archived. So all of these people are not archived, and their average age is 30. These 2 people are the ones who are archived, and their average age is 48. So you can then see at this point how the over clause with different partitioning parameters can be used to come up with different grouping and collections of data there. And I think about like using SQL Server Report Server and reports that you build there. There's a lot of stuff we've done that could have probably been made a lot easier if this had been known by a lot of people working on those in the beginning. All right, so just to make it interesting, we need to throw in another female, Martha Washington, to help with the numbers and the averaging and those kind of things. We added 1 row. Now let's take a look at another option here. So I'm going to say select row number. So row number it's going to give you a row number for every result that comes back. So let me just show an example of just row number without any grouping or order by or anything like that. So here's a simplified query. Give me select star, but also give me row number from team. And row number must have an, that doesn't work. I forgot that you have to have the over clause in that one. So over the entire table like that. So if we look at row number over the entire table, it has to have an order by. So because the row number doesn't make sense unless you're ordering in some way. So let's see if this one works now. Okay, so what this has done is it's ordered the entire table from 1 to 14 here by age. 18-year-olds first, Ben Franklin down at the end, and everyone in between with this number here that's, you could almost say it's kind of like a rank of everyone's age at that point because of how we've ordered it. But next week in the class, we're going to cover a bunch more on ranking and different ways to do ranking. This is kind of like the, if you didn't have a way to rank people, you could sort of use that. If we use row number, partitioned by gender, order by age. So for all the women, order them by their age, and for all the men, order them by their age. And then down here, we're saying order by gender and age rank by gender so that we can get them so they're not scattered all over the place. But let's just skip the order by for a second. It ends up effectively ordering by the same way we wanted it anyway, but that's not guaranteed depending on what other stuff. So you can see that there are 2 females. The youngest one is Betsy Ross, and she's first ranked. The older one is Martha Washington, she's second ranked. And then of all the men, there's 12 of them, and that's their age rank spread out over the whole thing. So you can see how if you're trying to come up with some report of ordering or sorting, or like, let's say it was grades in a class and you wanted to rank everyone by their percentile, you could sort of get in that direction with what we're doing here. So technically in that case, the order by wasn't needed, but it came back with the right set, but I usually include it to make sure that we're going to get it in the right order that we're expecting there. So we get the same thing back. All right, so let's make it a little bit more interesting then with row number, row number, row number, row number. So we're going to be, row number is basically sorting all these people over partitioning by gender, name, the length of their name, their length of their name in backwards order, descending. Keeping in mind here, we're partitioning by gender. So this is going to be the same thing we did here. Show the men and women sorted in their own gender by youngest to oldest. But this will show the row number of them alphabetically. This will show the row number of them by the length of their name. And this will show the inverse of that. And then we're going to order by gender and age rank by gender. So here's gender is just one of the default columns, and then age rank by gender here. I don't like, well, yeah, let's try that first and then we'll make a change to it. So when we run that, you can see for any individual, let's take Alexander Hamilton. He's age 21, which means he's the 5th youngest male. He has the second name alphabetically after Aaron Burr. And then he happens to have there's 12 people with shorter names than him and 1 person with a longer. So he's the second longest name in the whole thing. And we can see down here who's got a longer name. Well, Lafayette here has the longest name. So you can do different slicing and dicing of the data and different sorting effectively based off of this different set of a windowed view of the entire thing. So if we wanted to say, replace the age rank by gender with the name length rank inverse, it's now going to sort the entire, oh wait, I did that wrong. It's going to sort first by gender. Let's pretend we want to skip that one. And then just, so this will give us a list of all the same data we just looked at, but it's now sorted by the longest name to the shortest name in the entire data set. Again, it's always tough to come up with good samples here that don't apply to real data in our system. Kind of gives you an idea of how the over clause with different ordering and different partitioning can give you a bunch of really interesting data depending on what you're trying to analyze. The windowing functions we covered, that's what the overbuy is with the partitioning. And then Cody, you asked the question about, well, is that going to perform well, or is that going to be inefficient or whatever? So rather than making you squint and read the little tiny screen here in the PowerPoint, let's just actually run it. So I'm going to say include actual execution plan. I could have just hit Control M for that. And then go full screen again. And if I look at just this query to begin with, select category unit retail over inventory. So we're back to our inventory table, and I'm just saying, give me 2 columns out of the whole table. Yeah, let's just run that. When I run that, we now get the execution plan showing up here. Zooming in a little bit. So basically what it's doing to get the result set is it's going through the entire table and it's doing a clustered index scan, which is all we've got on that table is a clustered index, and it's saying, go through all the rows and give me all of the rows out of the table. And that is returning a total of 7 rows, as you can see down in the estimated number of rows in that list there. Okay, so that's an example of prior to all the windowing function, what it would be doing. So that's running this query, you're getting 7 rows back. Now let's do the similar thing. We're going to say, give me the category, give me the sum of the unit retail over partition by category, give me the count of everything over partition by category from inventory. So let's take a look at what the plan's doing in that case. Look at the plan. Let me zoom it in. Zoom to fit. There we go. That's what I was looking for. So this part here, the clustered index scan, is now 22% of the entire cost there. And what that was what all of the work was in the original query. So you can sort of do the rough math off of this and say that the new query is roughly 5 times the cost of the original query, or 5 times as much stuff is going on. But what's happening here is it's taking the original output of the original query, which is everything. It's got to sort it because of how we did the, where is it here? Partitioning by category. It can't partition unless it's actually sorted it. Segment, that's what's actually doing the partitioning. Table spool with a lazy spool. Now what this does in SQL Server is it says, take that result set, throw it off somewhere in a temp table, in TempDB, so I can use it later. And what it's then going to do is it's going to use that lazy spool here and the lazy spool there, and it's going to say, take that temp chunk of data that we threw off, stream aggregate. What that's doing is it's doing a scalar operator on an aggregate. So that would be either the sum or the count. It's probably the sum at that point. It's computing the scalar against that. And then down here, it's doing the lazy spool and bringing it together. And that's probably the count. And then it brings those all together. The nested loops is taking multiple result sets as if you had separate queries, bringing them together. And then the second one brings all 3 of those together, and then it returns your result set back. So you can see there's quite a bit more work going on here. But the aggregates that are going on aren't really the aggregate functions aren't really what's causing all the work. Most of the work is simply sorting the result set in a way that it can be used in those aggregate functions. Okay.
So if
Did
you're,
it in 0 seconds.
but if you're partitioning over different columns, I would imagine it starts getting more and more loaded.
There's 2 types of questions that I love. One of them is the questions that I just absolutely know the answer to.
Right.
And the other one, or those are the real easy ones. And the other one is the questions that lead to the next slide or the next query. So this is the one that leads to the next slide or the next query. So here, yeah. Did you look at these ahead of time? So here we have one, this highlighted part is doing the exact same stuff we did up here. But then we're doing unit retail and doing a sum partitioning instead of by category by the unit retail, which is just the price. Not a really useful one, but it just sort of shows the example there. So let's run this. And we can see that for food, let's scroll this down just a little bit. The results show food, sleeping, all the categories. Then it shows the sum of the unit retail. So that's the sum of everything in that category. and I didn't multiply times the quantity or anything like that, like you probably should have to get real counts. And then it counts, so that's the number of things in that category. And then it shows the unit retail. Then there's a sum of all of those. And then the count of the items partitioned by unit retail. So there's one at $7.99, one at $14, two at $19. You can see they're both there. One at $24 and two at $199. Okay, no big deal. But now let's look at what happens in the plan here. If we say zoom to fit. So if we look at this section up here, all of this was exactly what we just looked at on the previous query. It's doing a little bit more work here. It's doing some more sorting over here, segmenting, and that gives us our second set. And then that table spool is being used down here and being all brought together. And again, we see sorting is taking 45%, I think, 45% if I can,
42.
or 42, 43%, something like that. So sorting is still taking the majority of the work. And now the original work is down to 12%. So this is taking roughly 8.5 times as much work to run this query as the original query did. But we're doing it in a much more efficient manner than if we ran each one of those separately and tried to piece it together ourselves later. We've covered the over clause, basically how to group on stuff without a group by. Partitioning, how to chunk those groupings into different ideas, and how that does work with group by and how well it performs. So any questions on any of that? Next week, we'll be covering top N queries. Aaron will be doing that one, and then I'll be looking at ranking functions. Like what we saw in here, where we used the row number to sort of come up with a pseudo rank. There's a bunch of really cool ranking things we can do that are way more powerful than that using aggregates. So that's next week.